Hello and welcome to this second part of the QED lecture on hypothesis test 1. And having looked at the example of a t-test, we're now going to look at the ideas of sampling and measuring and how they're related to testing, building further on that example. So if you think about what we've found, I would argue there's three ways that you can interpret this and try and explain what's happened to give rise to that Usambara evidence. The first one is that the data is actually wrong. So the data you've got from the sample are wrong. So in that sample, earnings did not really go up by that much. Second possibility is that, okay, that's right, they did go up by that much in the sample, but in the wider population, they didn't go up. So it's just something happening in the sample. The third possibility is, okay, it did go up in the sample and also in the wider population. And it's number three is the one we're really interested in, because it's always the population is the thing you're trying to say something about, and generally it's much bigger, thousands or millions of people. So let's look at these one by one. What could cause the first stage to go wrong? So we got our sample, but we got the wrong measurements from that sample. The clue there is in the word, it's measurement error. So we've got measurement error here, and there's two possible explanations for that. Could be systematic errors, more likely to be too high than too low. For example, the household thinks that we're coming from sort of a taxation avenue, so they might try and underestimate the amount they've produced or sold, or they might think we're coming from some sort of people that are looking for someone to invest in, so they might exaggerate the amount they've produced. So for some reason that they're not quite getting the right answer, or perhaps they're just optimistic or pessimistic. So there's some sort of systematic bias. That's what we call non-random or systematic measurement error. Or it could be that there's no systematic problem, it's just random errors. People just slightly forget, or they over-report, under-report randomly. And this one's not quite so serious because the ones that you get that are too high tend to balance out the ones that are too low. Whereas in the first one, where it's systematic, that's going to lead you to overall, even if we take the average, you're going to get the wrong answer. So they both can cause inaccuracy, but the first one, systematic, is more serious. Okay, so those are the two ways we get measurement error. How about moving on to the next one? Those are the two ways that could give us the wrong answer from the sample. Okay, but then let's suppose that we got the right answer from the sample, but even so, earnings haven't risen in the wider population. How could that happen? Well, in that case, what's happened is we've got sampling error. So even though we have found out the true answer for our sample, it's not representing what's happened elsewhere. There's two ways that could happen again, and we can call those again non-random and random. Non-random is because the way we did it is flawed. So we're in a bit of a hurry, we just drove along, we picked households that are near the road, and they're probably ones that are going to be earning more because they're nearest the road. Or we picked people that were easier to contact, and they're people that didn't tend to be out in the fields working, so they had a lower return because they didn't have much of PT plantations to be working on, so they didn't earn as much. So for one reason or the other, the way we designed the sample meant that we either got systematically too little or systematically too big. So even though you got your answers from the people you talked to, they're not representative. That's A, non-random sampling error. B, well, here is the worst one because we did everything right by the book. We did a method of sampling that should, in principle, have given us a random selection without any bias in it. But just by chance, we just happened to pick, say, higher earning households by chance. And that's what we call random sampling error. So both those ways, random and non-random sampling error, would mean that even though we got the right numbers from the sample, it didn't represent the population, and in the population, in fact, earnings had not risen. However, if you can rule 1 and 2 out, then you get to 3, which is that mean earnings in the wider population have actually risen. So if you've got the right numbers from the sample, and the sample really has gone up 0.15 kilograms of tea per day, whatever it was, and you've also, that sample represents the population, you're left with definitely 3, that the wider population has actually risen, the earnings. So you can conclude like this, that, okay, that would mean that in 1990, we got this information, we know that the mean earnings was 0.12 kilograms of tea, and in 2017, in our sample, we know it's 0.15, but also that means that the mean for all the households in 2017 is higher. If we can conclude that, what we say is that the result from the sample is significant. So a significant result means what you're finding out from your sample gives you confidence enough to say that that is happening also in the population. That means the result is significant. And that's the third one. Now, what can tests do about this? Well, can a test help? I've put some more detail in here of the possibilities just discussed. Can a test sort out what's going on here? Well, before you do a test, you've got to make sure that the methods you're using to measure, get data from the household, minimize measurement error. You've got to make sure that the ways you're selecting a sample minimize sampling errors and are not biased. And if you make good choices, then you can keep measurement error down to a minimum, and you can restrict non-random sampling error down to a minimum. But it's really tough to get rid of all the random sampling error. Inevitably, luck is going to play a part, however you design it. That means that your random sample might throw up people that are a little bit too high on average or a little bit too low on average. So that's what tests mainly deal with, the fact you can't entirely get rid of random sampling error. So the tests don't address all these 4 different possibilities and tell you which of these 4 has happened or has the third one happened. That's not possible with a test. Tests mainly address between 2B and 3, and good technique, sampling and measurement technique and methods try and reduce 1A, 1B and 2A. You're left with the final one, 2B, and the one that you're often trying to show, which is 3, that there has been a change in the population. In other words, of all these things, I can grey out all the ones that tests can't really touch. Tests touch this one, which is the sample is correct, but not representative because of random sampling error, or it is representative and significant, and the earnings in the wider population have risen. So either there's something significant happening, the wider population has changed, or you've been misled by random sampling error. So tests help you decide between these 2 possibilities here. Unfortunately, having said that, no test is going to give you a definitive answer to say, yes, it was random sampling error, or no, earnings really have gone up. Can't be done. All the test is going to do is give you probability. This is more likely to happen, that's less likely to have happened. This is the range of possibilities or probabilities you can associate with each outcome. So tests tell us, they zero in on that little sneaky word there, by chance. So they tell you more about how big this is. So you want to know whether, is it true that mean earnings in the wider population have actually risen, or is it that it just happens by chance to pick some households that were that much more wealthy than other households, even though in the whole population nothing's really happened. If that was true, what would be the chance that you could go and pick a bunch of people and just by bad luck you happen to get ones that misleadingly have earned that much more? What's the chance of that happening? That's what a test will tell you. And then once you've grasped that, once you can do that, then the principle you apply to all tests, and particularly in the RCT examples, is the same. And we'll go on to that in the next section when we talk about the universal tester principle and apply that to RCT examples. But for now, thanks for watching.